Hi guys, this is the video for Learning Target 5. I'm going without my picture in the screen today because I don't want it to happen like in Learning Target 4 where I covered up some of the work and we have a lot of work to do today. So you should let me know in class if you like it better with you seeing me or not seeing me. So I'm going to pause this video, or why don't you pause this video right here and get down these 3 vocabulary words quick. So now that you've gotten those 3, I want to kind of talk about what we're going to do in this learning target. In learning target 4, we started to solve quadratics using just manipulation, algebraic manipulation. We subtracted from both sides, we square rooted both sides. You found out that we're always going to, or most of the time, going to have 2 answers for our quadratic equations because of that x squared. And because of the nature of parabolas, we know that parabolas often look like this, and they have 2 answers. Any y value will have 2 x values that go with it, unless we're at the vertex or unless we're down here where there's no values. So that's often why we have 2 answers. Let's talk about the different forms of equations. Let's first start with factored form. Factored form is what we've seen in FOIL. It's when an equation is written as the product of 2 or more expressions. So anything like x plus 3 times 2x plus 8. So anything like x plus 2 times 3x plus 4. That would be written in factored form because it's this expression times this expression. There's 2 factors there. Expanded form is when we expand that. So in this case, we'd use the FOIL method. We'd have 3x squared there, and then we're going to have 2 times 3x is 6x, and outside is going to give us 4x. So we have 6x and 4x plus 10x, and then 2 times 4 plus 8. So this is expanded form when it's just written out as a bunch of different terms. We also call this general form. Okay, and all like terms are combined. So notice I didn't write 6x plus 4x. I wrote 10x because we combine like terms. And then finally, the zero product property. If there's a product of 2 or more factors, so let's say that we have a and b, a times b equals 0, then at least one of those factors, either a or b or both of them, needs to be 0 because there is no other number that will create a product of 0 other than 0 itself. All right, so using all of that, we're going to move on to some examples. Here we're asked to solve each of these equations for x. All right, so right here, automatically I see that we have both of these equations written in factored form. It's something, some expression times some expression. We're multiplying this expression times this expression times this expression. In both cases, we have factored form. I also notice that in the y's, we equal 0 both times. So that means we can use the zero product property to say that either 9 minus, or x minus 9 is going to equal 0, or that 3x plus 4 is going to equal 0, because we know one of them has to be, both of them could be, for that our product to equal 0. So if we go ahead and just solve this, this means that x is either going to equal 9, or quickly solving this one, x is going to equal negative 4/3 over here. Okay, so we have 2 answers because we had 2 factors. All right, and this would look like a parabola with 1 root at negative 4/3 and 1 root at 9. Okay, and then over here we can look at these 3 factors. We're going to either have 4x equals 0, we're going to either have, or we're going to have 6, or x plus 6 equals 0, or 4x plus 9 equals 0. So that means that x is either going to equal 0, negative 6, or negative 9/4. okay, or negative 2 and 1/4. And this is actually not going to be a parabola because we're going to have 3 x's. So we have 3 solutions because we had 3 factors. All right. Moving on, now we're going to need to factor. And yesterday or Tuesday in class we talked about some of this undoing foiling is called factoring. And it's also using the distributive property but using it backwards. So we're asked to solve each equation for y equals 0. So first I'm going to set this up so that y equals 0 in all of these equations. So this is going to be x squared minus 2 equals 0, 2x, excuse me. This is going to be, if I subtract 5x from both sides, 2x squared minus 5x equals 0. Okay, and I'm just getting everything on one side so that we can pull out factors. This will be x squared plus 10x plus 25 equals 0, and then this will be the same one, equals 0. Okay, so we're asked to factor, and then we're going to use the zero product property to find our zeros, to find our roots, and we're going to find out where y equals 0. So looking at this one here, I'm going to do the distributive property backwards and say what can I take out of each of these two expressions that will be multiplied back in. So, okay, I see that there's an x in both of them. So if I take out an x, then I just write in the parentheses what's left over. If I take an x out of x squared, then I have 1x left over. If I take an x out of negative 2x, then I just have a negative 2 left, and that will be 0. So now I know that either x has to be 0 or x minus 2 has to be 0, because those are my two factors. So either x equals 0 or 2 equals x, right? Because 2 minus 2 will give us 0. Over here, again, I have to figure out what can I take out of this equation or of each of these terms to get a factored form. So again, I see that I can take out an x, and if I take out an x from 2x squared, then I have 2x's left. And if I take out an x out of negative 5x, then I just have a negative 5 left. And so if that equals 0, then again, x either has to equal 0 or 2x minus 5 will equal 0. So that's going to be 2x equals 5, or x equals 5 halves, or 2 1/2, right? So those are my two answers there. So that's kind of an example of when you're just using the distributive property. Over here, when we have 3 terms in our equation, we can do kind of what we did in the daily math yesterday, looking at foiling backwards. So what's going to happen when I have 3 terms here? I have 2 factors that are going to equal 0. Okay? And to help us out, I'm going to draw our boxes and just kind of go backwards. So I know that these 2 terms have to equal x squared, and an x times an x will give us an x squared. And I know that also that my final box is that number, usually a product of these two, the other 2 numbers in here. Okay, and so I need something where my product is 25. So factors of 25 are 25 and 1 and 5 and 5. Okay, and so obviously 25 and 1 that wouldn't give us, if we foiled, wouldn't give us 10x. What is going to give us 10x is if we put 5 and 5 here. So this would be 5x, and this would be 5x. And then these 2 add to that middle term. And we saw that yesterday in the daily math, where they added to the middle term and multiplied to the last term. So we're going to have x plus 5 in one parentheses and x plus 5 in the other parentheses. We could also write that as just x plus 5 squared, which we'll see later. Okay. So if we talk about the zeros in here, negative 5 will make this be 0, so x equals negative 5. And negative 5 will also make this equal 0, so we really only have one solution there. Okay. Over here, let's do the same thing. Let's make our boxes. I'm going to need 2 factors to equal 0 here. All right, so again, I see x squared, so that means that x and x will give me that. And then over here, I have a negative 42, which means not both, but only one of these numbers is going to have to be a negative, because both negatives would give me a positive product. All right. I notice, though, that my sum is going to be positive, so the bigger number is going to be positive to get that difference of a positive 11. So let's take a look at the factors of 42. 42 would have 42 and 1, obviously, would have 21 and 2, would have 14 and 3, and then 7 and 6. So I'm looking for a difference of 11 here. 21 and 2 don't have it, 7 and 6 don't have it, 14 and 3 do. So that means the bigger number has to be 14. So I'm going to have a positive 14, and I'm going to have a negative 3. So this would give me a negative 3x and a positive 14x, and those together would give me 11 x's if we are doing our FOIL method. So my final factors here are x minus 3 and x plus 14, which means our zeros would be 3 and negative 14. Those would be the places where the parabolas cross the y-intercept. Okay. All right. A couple more here. Let's look at x squared minus 13x plus 42. So I have the same factors here, so I'm going to set up the same box. This time, though, we have a positive 42. And if we look at our factors, positive 42, we have 21 and 2, 14 and 3, 7 and 6. But I notice we have a negative sum. So that means if x and x go there, both of these numbers are going to have to be negative so that they create a positive product and a negative sum, because only a positive times a positive or a negative times a negative will create that positive sum. So I need 2 negative numbers that add to negative 13. 21 and 2 don't do it. 14 and 3 don't do it. 7 and 6 would. So a negative 7 and a negative 6 would give me a negative 6x, a negative 7x, and that would add to a negative 13x. So my factors here would be x minus 7 and x minus 6 equals 0. Okay, so my zeros would then be what makes this 0, 7. What makes this 0, 6. Those would be my zeros. That's where my parabola would hit. So this is going to be a really skinny parabola at 7 and 6. Okay, let's do one more. Here I need to solve for 0, so I'm going to get rid of this 10 on both sides so that I have 0 equals x squared minus 3x minus 10. Set up my box. I see that we have x and x equals x squared. And then I have a negative 10. Negative 10. So let's look at the factors of 10. We have 10 and 1. We have 5 and 2. We have, that's it. Okay. So 10 and 1 obviously don't give me a difference of negative 3. 5 and 2 give me a difference of 3. But my negative is going to have to be bigger so that my sum stays negative. And then adding 2 gives me 2x and negative 5x, which would give me a sum of negative 3x. And so I have x minus 5 and x plus 2 equals 0. My zeros, what makes this factor 0 would be 5. What makes this factor 0 would be negative 2. And those are my zeros there. Before class, try to solve each of these problems. Okay? Try to solve and try to write them in the opposite form. Okay, so this one, write it in general, solve it, and then also write it in general form. This one, try to factor it and write it in general, and solve, factor it, and then solve. And this one too, factor, and then solve for y equals 0. So this one you're going to have to change so that y equals 0.